Hello students, welcome to the session. Today's topic for the session is measures of dispersion from the chapter statistics. So we will discuss this topic, measures of dispersion. So let's start the session. See, first we will start by taking some examples like calculating the mean of the data, mean of data. So after few steps, after few questions, we will understand what is the need of dispersion. Okay, so we can understand this through some examples. Let us understand this through some questions and examples. So let us calculate a mean of a data. Suppose we have given a outcome like 1, 5, 9, 13, 17. Okay, so we have to find the mean. So mean means average. So in simple word, we by the mean we understand it means average. So now we have to calculate the average of this data or mean of this data, that will be 1 plus 5 plus 9 plus 13 plus 17 by total number of outcomes 1, 2, 3, 4, 5. Okay, that will be your 30, 30 plus 10, 40, 45 by 5, that is your 9. Second, this is your first example. Second, we have another data 3, 6, 9, 12, 15. So we have 3. Again, we will calculate the mean 9 plus 12 plus 15 by 5. So we will have again 45 by 5. We will have 9. Similarly, let us calculate again mean of this data 10, 11. So this will be 7 plus 8 plus 9 plus 10 plus 11 by 5. Okay, so we will have 20, 20 and 10, 30, 30 and again 45 by 5. That is our. So in all these cases, we have calculated the mean, and mean comes out to be 9. In each case is 9. So that means the average value of this data, the given data is 9. So if we are saying that its average value is 9, so if we see the result, this is 9 is our result. Okay, this is 9 is our result. So by seeing the result, can we analyze, can we say that our our data elements are around 9, just nearby 9? Can we say that? Can we say that? See, in statistics, why statistics is important? Statistics is all about the collection of a data. So if we have some data, we can say, if we have some data, if we have some data of any particular event. Okay, so if we have a data of any particular event, by that data, by that value, we can predict the whole event. We can predict the whole event. What can we can analyze the whole event? That means, see, let us understand by example. In in our mobile, there is an application which gives you the average screen time. Okay, the average screen time. So average screen time, it shows every after 1 week. Okay, it shows every after 1 week. So let us suppose it shows 8 hours per day. 8 hours per day. Okay, on Sunday, it will show you a result that your average screen time is 8 hours per day. So that means Monday, Tuesday, Wednesday, Thursday, whole week, you are using the mobile approximately around 8 hours. One day you used for 10 hours, one day you used for 6 hours, 7 hours. Okay, just around our value for each day is revolving, is circulating, is navigating around 8 hours. Okay, it is navigating around 8 hours. So by that single value, we can estimate that our daily our daily usage must be around 8 hours. Okay, so by the single data, we can calculate, we can analyze our daily consumption, daily data, daily based data. Similarly, in statistics, if we have one data, so can we analyze our exact data? Exact data. Can we analyze our exact data? That must be around revolving around 9. Is this event, is this experiment is revolving around 9? No. Is it not revolving around 9? My average is 9, but here one outcome is coming out to be 1, coming out to be 5, coming out to be 17. It is so much far. It is so much far from 9. We can't imagine these values which are too much far from 9 from our average. Little bit variation is possible, but this is not permissible. Similarly, in second case, you also got your average 9. So that means our data value should be around approximately 9, 10, 11, 12, that much variation. But it is coming out to be 3 also. It is coming out to 15. So much variation. So much variation, right? Similarly, in 9 case, in third case, you are getting an average of 7. Okay, it is permissible. But 9, 11, this data is something which can be concluded. But in first and second cases, we we can't use this data to say that our our result data, our result that was given are not around 3, are not revolving around 3. So there need to be some value, and some variation needed which can give you the exact data. Okay. So by this average, by this central tendency, by this mean or by this median, we can't say our exact data value is revolving around the mean or around the central tendency. So for this correction, we require a dispersion. So what is this dispersion said? Dispersion said that, so the definition of dispersion comes like this. So it will eliminate the variation. Okay, it will tell you the variation. So that much variation is in this data. That much variation is in this data. Can imagine your value up to that level, plus minus 20, plus minus 30 in this bracket. Okay, within this bracket you will get your data. If you find out the complete mean, median, mode, or the something like that, from by seeing that value, you will get a measure of dispersion, that plus minus 30 is your variation. In this plus minus 30 bracket, you will get your required, you will get your data of the outcome. Okay, clear? So now let's clear this dispersion. Okay, let's, before starting this dispersion definition, I give you another example. So if you are given a raw data, so this dispersion is very much important because it will give you the variation, and if you know the variation, you can find the exact value. So there is two batsmen, batsman 1 and batsman 2. Batsman 1, these are the matches he played: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And batsman B played 30, 91, 0, 64. These are the scores: 42, 80, 30, 5, 117, 71. Similarly, this is your 53, 46, 48, 50, 53, 53, 58, 60, 57, and 52. So these are the runs scored by this batsman. Okay. So now the mean and median. So this is the final data, final value, central tendency value. By seeing that, can we analyze, can we predict our complete data? It is 53, 53. For batsman 2, it is again 53, 53. See, by seeing the 53 value for the B1, for the batsman B1, can we say that our batsman B1 average is approximately around 53, 54, 60 up to? No, we can't say, because see, there is a huge variation of 10, 0. There is a huge variation in 5 also. So by seeing that, we cannot predict our main results. Okay, we cannot predict our main results like this 117, so much variation. Okay, similarly from 53, we cannot, by seeing one value, we cannot predict our data should be around like this. Okay, so for batsman B2, this is 53. Okay, the yes, in this case it is something permissible. Okay, it is giving some value which is nearby 50 only. So it is clear that there is a huge variation, and for this variation we have to minimize, or we have to know how much variation is permissible. So for this case we require a dispersion, measure of dispersion. Due to this, dispersion is required. How much variation is possible? How much variation? See, in average, it is always thought that our values are revolving around that values only, 53, 54, 60, and 55. It is something which balances. But there is a huge gap between 0, 53 to 0, 53 to 5. Okay, so that is not acceptable. So due to this, we require a dispersion. This dispersion will tell you the variation, the gap. This much gap is possible. So let's now understand the definition of dispersion. So measures of dispersion. I hope you understood why it is required. Okay. So the dispersion is the measure of this variation. The dispersion is the measure of variations in the values of the variable, that result variable that was given. The dispersion is the measure of variation in the values of the variable. It measures the degree of settlement, degree of scatteredness. The values which are going, if your 53 is your average, one value is at 0, one value is at 117. So it measures the degree of scatteredness, okay, of the observation in a distribution around the central value. Around the central value. That central value means the central tendency, mean, median, mode value. Mean, median, mode value. Okay. So everything we are expecting from this value only, mean, median, mode. From seeing this, we are predicting our observation, we are predicting our that values, outcome values should be like this. So this dispersion will give you the perfect answer. Okay. So that's all for today's session. I hope you understood the topic well. If you have any doubt, you can contact me through Urban Profile app. Till then, revise. Let's meet in the next session. Thank you.